Module 2 Random Process. A random process is also known as stochastic process. A random process x of t is used to explain the mapping of an experiment which is random with a sample space S which contribute to sample functions x of t lambda I for every point in time t1, and x of t1 is a random variable. T represents time and it can be discrete or continuous. The range of T can be finite, but generally it is infinite. It means the process contains infinite number of random variables. Example, rolling a dice. Let random variable is xj, where j is the value displayed on top of the dice after rolling. Random process is y of t equal to x cos omega naught t. Ways of viewing a random process. Let's take a process x of t omega. When t is fixed, x of t omega is a random variable and is known as a time sample. When omega is fixed, x of t omega is a deterministic function of t and is known as realization or a sample path or sample function. Where omega brings randomness in x of t omega, in further notations omega is implied implicitly, so it is generally suppressed. When t belongs to countable set, the process is discrete time and it denotes the time index. A random process can be written as x of n omega or xn for every n. Xn is a random variable which can be discrete, continuous or mixed. When t belongs to uncountable infinite set, the process is continuous time. Random process can be written as x of t. Specifying a random process. A random process can be specified completely by collecting the joint cumulative distribution function among the random variables x of t1, x of t2, etc. x of tn for any set of samples for time t1, t2, etc. tn and for order n. Denote xk equal to xtk. If process is continuous, then it can be expressed by collection of joint probability density function f of x1, etc. xn, that is bracket x1, x2, etc. xn. Deterministic and non-deterministic random process. When the future values of any sample's function are predicted depending on the knowledge of the past values, then the random process is known as deterministic random process. A random process is the combination of time functions, the value of which at any given time cannot be predetermined. So it is known as non-deterministic process. Example, let's take a random process x of t equal to a cos omega t plus theta where t greater than or equal to 0. This process has a family of sine waves and depends on random variables a and theta. So it is deterministic random process. Stationary and non-stationary process. Stationary. All joint density functions of the random process do not depend on the time origin. Here the mean values are fixed and it does not depend on the time with absolute values. Non-stationary. The probability density function depends on the time origin. At least one or more of the mean values will depend on time. We generally take stationary random variables, but this assumption may not be accurate in real situations, but considered in approximate one. If a random process satisfies the following conditions, the mean of x of t does not depend on time t, that is x of t equal to x. The correlation between any two random variables e of x of t1, x of t2 depends only on the time difference, that is t1 minus t2. Then it is called a stationary process in the wide sense. Strict sense stationary denoted by SSS. A random process is SSS if all its finite dimensional distributions are invariant under the translation of time. Question number 1. Consider random process x of t, where x of t equal to a cos omega t plus phi, denoted by f of phi t, where a and omega are constants. Phi is a random variable uniformly distributed in the interval minus pi pi. X bar of t equal to 0 then, and sigma square variance equal to a square by 2, and kxx of t tau equal to psi of xx of t tau equal to a square by 2 cos omega tau. Ergodic and non-ergodic random process. Ergodic. Every number of random process has the same statistical behavior as the entire random process. The statistical behavior can be determined by examining only one sample function. Such processes are called ergodic. The mean values are determined by time averages. Ergodic processes are also stationary processes. Non-ergodic. It is opposite to ergodic. There is a possibility that the stationary process can be non-ergodic. Next is cross-correlation. Cross-correlation is a measurement that tracks the movements of two variables or sets of data related to each other. In its simplest version, it can be described in terms of an independent variable x and two dependent variables y and z. If independent variable x influences variable y and the two are positively correlated, then as the value of x rises, so will the value of y. If the same is true of the relationship between x and z, then as the value of x rises, so will the value of z. Variables y and z can be said to be cross-correlated because their behavior is positively correlated as a result of each of their individual relationships to variable x. Cross-correlation can also occur with sets and time series of data. State the four types of stochastic process. The four types of stochastic process are discrete time, discrete state random process, discrete time, continuous state random process, continuous time, discrete state random process, and fourth one is continuous time, continuous state random process. Example, consider random process x of t defined by x of t equal to a cos omega t plus theta, where a and omega are independent and uniform random variables over the interval minus k and minus pi respectively. First one, find the mean of x of t. Second one, autocorrelation function Rxx of t1 t2 of x of t. Autocovariance function Cxx of t1 t2 of x of t, variance of x of t. So we are given that a and independent random variables. Since a is uniform over minus kk, the probability density function of a is given by omega is uniform over minus pi pi. The probability density function is given by, totally we can write it as f theta of theta equal to 1 by 2 pi if minus pi less than theta and 0 otherwise. Next one, if x of t is a WSS process with autocorrelation function Rxx tau, and if y of t equal to x of t plus a minus x of t minus a, show that Ryy tau equal to 2Rxx tau minus Rxx tau plus 2a minus Rxx tau minus 2a. Since x of t is a WSS process with autocorrelation function Rxx tau, we know that Rxx tau equal to E of x t plus tau x of t. It's a function only of the difference of time. Since Ryy of tau equal to E of y of t plus tau y of t, it follows that Ryy of tau equal to, we are writing the formula E of x of t plus tau plus a minus t plus tau minus a. into x of t plus a minus x of t minus a by the definition. And then we are opening the bracket and solving, clubbing all the terms together. So we are getting the result. So what we have to prove. Next one, consider random process x of t defined by x of t equal to u cos t plus v sin t, where u and v are independent random variables, each of which assumes the values 2 and 1 with probabilities 1 by 3 and 2 by 3 respectively. Show that x of t is a wide sense stationary and not strict sense stationary. So first we have to calculate the first and second row moments of the random variables capital U and capital V, which are identically and independently distributed taking the values. So first we are finding E of U, and so that's equal to E of V. So that's equal to minus 2 into 1 by 3 plus 1 into 2 by 3. So the total we are getting 0. Now we are finding E of U square and E of V square. So 4 into 1 by 3 plus 1 into 2 by 3, 4 by 3 plus 2 by 3 equal to 2. E of U cube equal to E of V cube, so that is equal to minus 8 into 1 by 3 plus 1 into 2 by 3 equal to minus 8 by 3 plus 2 by 3 equal to minus 2. Next, we show that the random process x of t equal to u cos t plus v sin t is wide sense stationary. So for this purpose, first we calculate the mean of x of t. We find that mean E of x of t equal to E of u cos t plus v sin t. That is equal to E of u cos t plus E of v sin t. So both are zeros. We are getting the 0 plus 0 equal to 0, which is a constant. So now we calculate the autocorrelation function x of t. So we find that our x of t1 t2 equal to E of x t1 x t2, and we are giving the values u cos t1 v sin t1, u cos t2 plus v sin t2. So when you are expectation, when you are finding you are getting the sin t1 minus sin t2, and then we are doing that's equal to we are getting 2 cos t1 minus t2. So which is a function of t1 minus t2. Therefore, it is a wide sense stationary process. Next one, let x of t be a WSS with autocorrelation function Rxx of t equal to e raised to minus a mod tau. Find the mean and variance of x of t. Find mean and variance of time average of x of t over time minus t to t. So then E of x of t is we can find easily it is 0, and variance using the sigma square it must be 1. And second one, mean and variance of the time average of x of t over time, so that is also 0, and the variance we can find like variance we are getting it as sigma square, and then Cx of t is the autocovariance function of x of t, and that's equal to Rxx of tau minus E mu square, that is e raised to minus a mod tau equal to e raised to minus a mod tau. So that is we are getting the sigma square, that's equal to 1 by 2 this thing. So that's equal to 1 by 8 t integral 0 to 2t 1 minus tau by 2t d of e raised to minus a tau. So that's all in this module. Thank you.